Hello, everyone. Thanks for joining this session. I'm Sateesh Mamidala. I'm a distinguished engineer at Capital One. So I've been in the observability space for a long time, about 6 to 7 years. And we are from the central observability team from Capital One. We manage all the observability solutions that are used at Capital One.
My name is Joseph Knight. I'm a senior lead software engineer at Capital One. Same team, and my focus is on traces and trace sampling.
Right. Today we are going to talk about how we implemented trace sampling with OpenTelemetry and what are some do's and don'ts and how we are able to get there. So when we talk about observability, especially with tools like OpenTelemetry, we deal with massive amounts of data. The default for all the distributed tracing is it creates trace for every request that is coming into your application. So at scale, this can lead to massive amounts of data because trace captures a lot of information that each transaction is going through different services within your ecosystem. And you also have a metric signal, and metrics gives you the aggregated view. But when you collect all the traces, the fact is you don't really need all the traces to observe your system. You only want to look at the traces which represent a unique behavior that is happening in your system, right? And whereas metrics gives you the aggregated view, you can have all the metrics that can give you the count of each unique behavior. So when you combine these two signals, you get the full observability into the system. So when we started with OpenTelemetry, we started slowly, we didn't have a lot of data, but over the time, we reached really into petabytes per day of data. That's when we started looking into what is the effective way to implement sampling for the traces. So what are some of the implications if we don't do sampling? The first thing is a cost explosion, because capturing every single trace, it is very expensive on the storage costs and also the pipeline cost or the network cost or at the destination platform costs as well. Because if you try to send all your traces to any vendor system, they are going to charge you huge amounts for all the trace data that you have. And also the resource requirements, like if you are maintaining your pipelines, that means you have to deal with all this maintenance and the infrastructure costs as well. And it also creates a needle in a haystack problem, because you don't need 100% of the traces to get monitoring, but you are only interested in those 1% or less than 1% of traces that show unique behavior, right? And to see that, you don't need all of the data, but you need only that 1% that should pop out when you have any incident. And you also have repetitive data, because all your successful transactions that are within your SLO, you don't care about those much. So what is the solution? Obviously, the trace sampling is a seamless solution, but the implementation of trace sampling, that's where it gets tricky and it gets complex. Where do you really do the trace sampling? And it really depends on a lot of factors, like how your applications are deployed and how your observability is done inside your organization, right? And if you do trace sampling, you are going to get all of these benefits, like cost optimization, because it also depends on where you are dropping your traces, whether you can drop the traces at the source itself or during the pipeline or before saving it into your database. So if we look at any large organizations like ours, this is how it typically looks. You have thousands of services, and for some of your traces, they could have spans like 20 or 30 spans, because that each transaction is going through 20 different microservices or systems, right? And you don't want to look at all these greens, but if you do the trace sampling, that means you are only showing the unique behavior. That means you will see the reds will pop up a lot. That means you will have quicker insights into your system on what system is failing and how it is performing. So when we started with our trace sampling journey, we closely looked at how we are operating inside the organization. So we have customers who are instrumenting their applications, and we have a central observability team that provides the standards and guidelines on how to instrument their system and create standards and provide tools for the systems for how to instrument and how to visualize and all of that. And at the same time, the teams have to follow those standards in most of the cases, and they have to instrument their applications themselves. So based on all of that, we came with 4 pillars that we want to achieve with sampling. Even though we are doing sampling, we want to have the full trace. That means if a trace has 20 spans, when we are doing sampling, if we keep one span for the trace, we want to have all those 20 spans that are belong to the space. We want to sample all of those. Because if we drop even one span from that complete trace, we'll go into the fragmentations. So we don't want to do that. That means for every sample trace, we want to keep all the spans in that. And then we are also dealing with hundreds of application teams. We don't want any disruption to the application teams. That means we don't want the sampling decision to be happening on the application side. Means we don't want them to add any configuration in the application side. And also as we are a central team, we want full control of the data ingestion as well, because in the future, our rates might change, and we might want to change the sampling percentage or sampling rates, or how we want to do the sampling on sampling patterns. We want to keep that full control. And at the same time, we also want to use the open source components.
Thanks, Sateesh. So with these goals in mind, let's figure out what our options are, right? So the way we're deployed, we're using the gateway collector pattern to build that hub and spoke that you see commonly with OpenTelemetry, where all of our instrumented applications are publishing their telemetry into the centralized OpenTelemetry collector deployments in a gateway fashion. And from that gateway is where we're exporting across the expensive network links, incurring vendor costs, hitting those storage limits. So that's our costly link. We want to interrupt those traces before they get there. And the first place to do that is all the way at the origin. We do head-based sampling. And head-based sampling is awesome, but it has some of those client correlation or coordination challenges. We have to go out to all of our instrumentation across all these application teams and make sure they're all going to follow the spec. And that's not necessarily going to be the default behavior. Now, we can also look at it at the OTel gateway perspective, and this brings 2 new strategies in. We can do probabilistic with the probabilistic processor coming out of the OpenTelemetry contrib project. This is actually really good because it approximates that head sampling, but it eliminates that need to coordinate all the services. We can kind of provide that trace completeness guarantee without any crosstalk. But doesn't solve the problem of finding the actual important traces, right? We can do probabilistic, we can grab a percentage, but as soon as we open up and look into the trace, we need something more to keep the completeness property. And that's where tail sampling comes into the picture. Now we're talking about looking into all the spans for a trace and making some decision about whether to sample or not at the gateway. And this is doable, but it adds a lot of complexity. So let's look back at our goals that Sateesh outlined and kind of compare and contrast these. We can capture complete traces as long as we do it at the gateway, because as a central team, we can enforce those rules. We also minimize the client-side changes if we do it at the gateway. So probability solves us here. But when we get to the control aspect, that's where tail sampling stands out, right? It gives us control over exactly what we want to sample, what we don't want to sample, rules, how to filter. That's what makes tail sampling the solution we wanted to implement. But like I was saying, that adds a lot of additional complexity to deployment. So this is the part where here's some considerations you should make if you're going to be deploying tail sampling in your organization using the open source tail sampling processor. The first thing to consider is that this sampler does not come out of the box with a rule set. You have to define what makes sense for your organization. It will give you building blocks like the ability to select for specific attributes, state, run OTel statements, look at latency. You have all these building blocks, but the first thing you need to do is decide what trace groups you want to capture. A good example of this is using an attribute or OTel statement to pull HTTP response values out of your spans. Once you have a group of traces that you want to sample in a particular way, you need to decide how many of those you want to capture. And this is where some of the tools like always sampling, probabilistic, or rate limiting come into factor. Probabilistic lets you grab like a percentage of a certain trace group. Rate limiting allows you to say, I want this many traces per second of this type. And once you have these two rule sets, use the combinations like ands and drops, or even a like layered composite to pick which slices of which trace groups you want to capture. And in this way, you can build rules that capture specific behaviors that you know are important to your application teams. In our deployment, we were deploying for a central gateway across thousands of applications. So we focused on keeping these rules really simple so that application teams knew what to expect from the traces that they're publishing into our OTel sampling gateways. But once you deploy these gateways in kind of that layered approach with the sampling exporter, the load balancing exporter, and the sampling processor, you have another key decision to make, and that's the decision wait time. We have this rule set. We have to decide when to run the rule set on each trace. The way the tail sampling processor handles this is the first time it sees a trace, as in the first time it's received a span for that trace, it starts a timer. And when the decision wait time timer exceeds the specified value, it runs your rule set. So you're presented with a trade-off. A longer wait time gives you more accuracy to look into more data from your trace, but at the cost of more memory buffering and a longer latency on delivery. So this is like a tug and pull. You can't like perfectly answer this question. One thing that we found is that if you're just trying to optimize for cost, you can look at a 99th percentile or even 95 percentile duration trace and shoot for that as your effective tracing target. And just sample everything longer than that with a latency policy. And this solves that long tail problem because it's not adding a lot to your cost, but it allows you to use a significantly smaller decision wait time than you would if you tried to capture like all of your traces. This also speaks to sizing the collector. You can shrink your decision wait time, then you don't need as much collector memory to handle a specific trace volume. But it is worth considering that when you're dialing your buffer sizing for the collector, you're doing it a lot in terms of trace counts, even though you don't know in advance how big your traces are going to be. So using large collector sizes and then auto-scaling from that point makes a lot of sense because you can take advantage of this median average trace that gets spread out across your collector fleet. And then leveraging the self-health metrics in the collector are key to making sure that your assumptions prove accurate and that you're in good shape to deal with trace surges from increased customer behavior. Lastly, we found that in coming from a world where we were tracing and capturing everything to one where we have only sampled data available for teams, there are two things that made this easier for application teams to make the most of this data. The first is that we add tags to the traces that we sample to tell teams how their traces were selected for sampling and at what ratio, from a probabilistic perspective, they were sampled. This allows teams to estimate or extrapolate using the data in the monitoring tool to make a good guess at how much original trace data was generated. In the same line, if you can teach teams or applications like SRE teams to use metrics along with spans, they're going to have a much more accurate picture of how their system is behaving. Like Sateesh was saying, we export in the semantic convention metrics, histograms, for every single span that we generate, both on the server and the client side. Using those to get accurate counts means you don't need every span to understand the rate of your system. But if you're coming from a world where you were sampling everything to a world where you're not, your developers are probably going to just bias into that span counting behavior. So building tools and rules and guides for how to translate those tools, alerts, dashboards over to use metrics can make that transition easier. So looking at our deployment, we saw two key benefits to getting trace sampling deployed out to our production environments. The first is that now as a centralized team that's managing these platforms, we have control over the cost of our distributed tracing. And what that meant for us is that we can now make changes now and in the future to ensure that widespread adoption of distributed tracing is possible with the budget and allocation of resources we have for OpenTelemetry. But also very important, we can provide guarantees to application teams that they will be able to see certain behavior in their tool. If we say, oh, you're going to be able to see this error, that can build a lot more comfort in how sampling affects the traces coming from their application in a way that can't be achieved with like a probabilistic or head-based sampling. In the end, we went from saving from generation to ingestion 70% of our span volume, which is a very meaningful amount at the scale that we're operating. And kind of looking forward from here, we're looking at that 30%, we're saying, how can we make it better? And the big thing that we see is that there's this tug of war between high rate or high frequency or low frequency events in our probabilistic ratios. A tug of war between teams that are pushing a lot of rate through our system can handle a much lower probabilistic rate for some of their rules, whereas lower rate applications get starved at any lower ratio. And at the scale we're operating, we can't be tailoring the rule set to every specific application. So our focus right now is on building enhancements to the tail sampling processor that will give us the ability to adapt to the frequency of events we see dynamically, right, without config changes on our side. And excited to bring that research and publish it back as an open source contribution when we're ready. I think with that, we're here for a couple minutes of questions. There's a microphone in the center of the room, and we'd be happy to take your questions about our deployment.
Something that's come up for us is when we initiate trace sampling and stuff, we've been working through this process. Teams, as they develop, want to have additional traces outside of the sampling decision, right? That way they can make calls, validate everything's working correctly, run load balancing scenarios, that kind of stuff, right? Do you guys ever face that internally, or do you set this policy global and they have to deal with it?
So we have policies that can allow teams to operate differently in non-prod environments. So the way we've handled that is with an intake process, just to make sure that sampling is the default behavior, especially for production use cases. But for any use case that wouldn't be met with a metrics solution, we'll walk teams through an intake process, and that's how we take care of it.
It's just like whitelisting some of the services that don't need to go through the sampling process.
Okay,
So
that makes a lot of
we
sense.
just whitelist those, and all of those traces will be sampled. We don't drop any of those traces.
Okay, yeah, that's effectively our approach as well. I wasn't sure if you guys were doing something else. Thank you so much.
Just curious on the ballpark deployment size for your centralized collector, like thousands, hundreds of instances, and I know there's a lot of memory required for tail-based sampling, but basically I'm trying to figure out if my Kubernetes-based deployment approach is the right thing to do right now, or if I should go to more of a VM or bare metal type of solution.
That's going into some actual numbers, but
Yeah, we're
without
constrained on what we can share.
without
about-
trace
how about
sampling,
t-shirt size?
we are more than a petabyte per day without any sampling.
Right. And then just a real quick follow-on that's not related, the best practices you mentioned adding the sampler attributes to the spans. Is that what you were saying, just so you can see it within your actual tool to view like what the actual application is being configured to sample?
Yeah, so that's useful in two ways. One, you can do that estimation. So you can multiply out by like the average value of like a probabilistic ratio to get like the estimate for how many were generated prior to sampling. But the second thing that's nice about tagging the data directly is that if we change those ratios over time, the ratios get baked in with the source data.
Right.
So you can look backwards and you don't see jumps
Right.
or
Why did telemetry
adjustments over
change?
time.
Is it traffic-based versus configuration?
Right.
Got it. Thank you.
Hey, you had mentioned doing some sizing work when you started doing sampling, like you had to increase memory consumption, that sort of thing. Did you notice any differences in CPU utilization and like what kind of magnitude of the difference was there when you had tail-based sampling versus when you weren't sampling?
Well, it's not something we called out in the presentation here, but when you do tail-based sampling like this, you need to turn it into a horizontally scaling problem because you have to bring all the spans together for a trace before you can make a sampling decision. So when you're doing that, you're now layering your OTel collectors, right? So there's a load balancing exporter collector layer and then a sampling processor layer. And in our deployment, those are entirely dedicated to tracing. So there's not really a delta between before and after. These are entirely new pieces of infrastructure dedicated to the purpose of trace sampling.
Gotcha. Cool. Thanks.
Hey, thanks for the talk. I think you kind of touched on it, but I'm curious. How are the other engineering teams able to sort of interact with the centralized sampling decisions? So obviously you can control like what attributes, for instance, in like the collector configurations to look for to make decisions. And I'm talking outside of like latency and errors. But are teams able to interact with that through like a centralized service and make more customizable configurations for the traces to sample?
I think that'd be a really interesting idea. That's not how we've deployed it. The tail sampling processor as it stands today is pretty statically defined.
Yep.
There is some really exciting work happening in the contributor right now to allow dynamic config, like policy loading. I don't think that's well documented and ready for prime time, but should that become more available, I think the idea that you're presenting would be a really interesting service to build. But I can't speak to experience.
Right. Thank you.
OpenTelemetry allows for correlation between signals. So in logs, you have like pointing to a trace that it's sampled, yes or no. And in metrics, you have exemplars. Do you change those, or do you just ignore that? So if there's a log that says, "Hey, it's sampled," and you actually don't sample it, or drop it afterwards.
So since we are sampling at the gateway, the actual applications are just producing spans, not knowing whether that span is going to get sampled or not.
Okay.
And we're not factoring exemplars into that because we have separated the traces and metrics pipelines in processing that. So no, I guess there's not really any overlap, but could be. It's an interesting idea.
Yeah, we have different collector layers, like Joe said. A different set of clusters receive traces, metrics, and logs, and from there it bifurcates. Metrics will go to a different cluster and different destinations, and only traces will go to a sampling cluster with load balancer and all of that. So it's a layered architecture for collectors.
So you talked about using latency to do something with longer traces. What do you do? Do you just not sample them, or how do you handle those?
Actually, the reverse. So if you look at all the traces, you're going to see a really long tail, where some traces go on like exceptionally long periods of time. But the thing is, if your goal is to cut cost, that long tail is not really where you want to look. You want to look where the volume is. So the thinking that we had was, let's just sample everything that goes over a certain period of time. There's probably going to be waste in there, but in the overall percentage, it's not the cost driver. So if you add a latency policy that just samples everything, and as long as you have enough time to collect a picture of the trace, there's a bit of a heuristic effect where you just need a little bit more time in your decision weight to collect enough of the trace to know it's a long running. And then even if something happens that would otherwise affect your sampling decision after the fact, it doesn't matter, you've already decided to sample it. So that's what I meant by that strategy, is that it allows you to use a much shorter decision wait time and makes deploying the tail sampling processor a more practical reality. All right, I think
Let's
that
do
is
one
our
more
time.
question.
Thank you very much, everyone.
We can take one more.
Oh, one more. All right.
Yeah.
Before OpenTelemetry, how are you managing? I mean, before you implemented it.
A lot of vendor tools implement their own sampling strategies. So
Okay, so you're relying on disparate.
Yeah, again, a lot of vendor tools they're only providing the head-based sampling.
I'm sorry?
Head-based sampling.
Uh-huh. Okay, and then OpenTelemetry, how long did that take to?
OpenTelemetry gave us the new perspective that head-based sampling is not very effective, right? Tail-based sampling is much more effective because you're making the decision after you receive all of them and look at all the traces. Yeah, there's been a shift from head-based to tail-based, but the teams are very happy that they are getting a much more better picture now from the traces than before.
Thank you.
all right. Well, thank you, everybody. We appreciate your questions.
Thank you, everyone.